Case control studies identify subjects by outcome status at the onset of the investigation. Outcomes of interest may be whether the subject has undergone a specific type of surgery, experienced a complication, or is diagnosed with a disease. Once the outcome status is identified and subjects are categorized as cases, controls, or subjects without the outcome but from the same source population are selected. Data about exposure to a risk factor or several risk factors are then collected, typically by interview, abstraction from records, or by survey. These studies ask the question, do cases and controls have different exposure histories? Cases and controls should be similar to each other except for disease status. A case is selected because they have a disease or health-related outcome, while a control is matched on key characteristics to a case, usually demographics, and they should not have the disease or health-related outcome. Case control studies are well suited to investigate rare outcomes, or outcomes with a long latency period, because subjects are selected from the outset by their outcome status. Thus, in comparison to cohort studies, case control studies are quick, relatively inexpensive to implement, require comparatively fewer subjects, and allow for multiple exposures or risk factors to be assessed for one outcome. Case control studies use the odds ratio to analyze the data collected. The odds ratio, or OR, is one way to quantify how strongly the presence or absence of some property A is associated with the presence or absence of some other property B in a given population. If each individual in a population either does or does not have a property A, for example, high blood pressure, and also either does or does not have a property B, like moderate alcohol consumption, when both properties are appropriately defined, a ratio can be formed, which quantitatively describes the association between high blood pressure and moderate alcohol consumption for individuals in that population. Setting up a 2x2 table is the first step when calculating an odds ratio. Columns are always the disease status, and the rows are always the exposure status. As you can see in this diagram, the boxes are labeled A through D. So those cases who were exposed will always be box A. Those controls who are exposed will always be box B. Those who are cases and not exposed will be box C, and those who are controls and not exposed are box D. They should always be labeled or thought of in this pattern. When you divide A by C, you get the odds of exposure in those who have the disease. When you divide B by D, you get the odds of exposure in the controls, or those without the disease. In order to get the OR, you can divide the odds of exposure in those who have the disease by the odds of exposure in those without the disease. Using mathematical properties, you can also think of this formula as A times D divided by B times C. This is an example of a 2x2 table for a case control study of lung cancer and smoking. As you can see, the disease status is in the columns, while the exposure is in the rows. What is the OR for this table? Here you can see the odds of exposure among cases was calculated, then the odds of exposure among controls. Finally, using those two values, the odds ratio was calculated. This odds ratio signifies that the odds of exposure to smoking among cases of lung cancer are 8.2 times as large as the odds of smoking among controls. Therefore, the odds of smoking among individuals with lung cancer were 8.2 times as great as the odds among controls, a magnitude that indicates an important association between lung cancer and smoking. Smoking could thus be a factor that increases the probability of having lung cancer. In this example, we are looking to see if vegetable consumption changes the risk of obesity. What's the OR for this table? Well, the odds of exposure to eating vegetables among cases was found to be 0.43 times as large as the odds of that exposure among controls. Well, an odds ratio of 0.43 times as large is kind of hard to understand. So if an OR is less than 1, we want to convert that decimal into percentage and then reverse the language in order to write a professional summary of what that result means. For this example, we would use 43%. Then we would subtract that from 100% in order to get 57%. In our write-up, we would say, the odds of exposure to eating vegetables among cases were 57% smaller than the odds of that exposure among controls. The results of this study show that eating vegetables was less likely to be found among cases than controls. Eating vegetables, thus, could be a protective factor. Hence, the odds ratio can also measure how much smaller the odds of exposure are among cases as compared to controls. This example shows a table looking to see if vegetable consumption was associated with depression. What is the OR for this table? Again, we calculated the odds of exposure among cases, among controls, and then from those values found the odds ratio. In this case, the odds of exposure to eating vegetables among the individuals with depression, the cases, are the same as the odds of exposure among controls. The odds ratio was found to be equal to 1, denoting a lack of association between the outcome, depression, and the exposure, eating vegetables. The results of this study do not show an association between eating vegetables and having depression. In summary, an OR greater than 1 suggests that an exposure is a possible risk factor for the outcome. An OR less than 1 suggests the exposure is a possible protective factor for the outcome. Finally, an OR equal to 1 suggests no association between the exposure and the outcome. Table 3 indicates that 51 of the 119 males who committed suicide had a mood disorder at the time they committed suicide, whereas 7 of the 91 male controls had a mood disorder. With this information, it is possible to construct a 2x2 table. This table is how we came up with an OR of 9. How would you calculate the OR for substance abuse? Well, if A equals 42, then C would have to equal 77, because 119, the total number of suicides, minus 42 equals 77. Well, and if B equals 4, D has to equal 87, because there's 91 controls. So 91 minus 4 equals 87. After this, we can calculate the odds ratio to equal 12, as shown in the table. This indicates that the odds of being a substance abuser was almost 12 times as large among suicides as among controls. Now examine the results in Table 3. According to this study, what are the 2 strongest risk factors for suicide in males? Having a prior suicide attempt is the strongest risk factor, with an odds ratio of 53. This result indicates that the odds of a previous suicide attempt was 53 times as large in males who committed suicides as in controls. Lifetime history of abuse was the second strongest risk factor, with an odds ratio of 49. In a cohort study, an outcome or disease-free study population is first identified by the exposure or event of interest and followed in time until the disease or outcome of interest occurs. Because exposure is identified before the outcome, cohort studies have a temporal framework to assess causality, and thus have the potential to provide the strongest scientific evidence of an observational study. Cohort studies are particularly advantageous for examining rare exposures because subjects are selected by their exposure status. Additionally, the investigator can examine multiple outcomes simultaneously. Disadvantages include the need for a large sample size and the potentially long follow-up duration of the study design, resulting in a high cost. There are three main types of cohort studies: retrospective, prospective, and longitudinal. The main calculation for analysis of cohort studies is the relative risk, also called the risk ratio, and it's abbreviated as RR. This image shows how to set up a 2x2 table for computing the RR. You can see that the disease status is still in the columns and the exposure status is still in the rows. You can calculate the RR by using the formula A divided by A plus B, which is the incident rate in the exposed, and dividing that result by C divided by C plus D, which is the incident rate in the unexposed. You can see in this image that the boxes are all labeled the same exact way that they were for case control studies. Here's a scenario for a cohort study. The numbers in the table were found or calculated using the information in the example scenario text. You will be expected to be able to extract this information from a scenario for both case control and cohort studies. While there is software that will calculate this information, it is important for you to understand how to calculate it by hand. So for this example, the RR is equal to A divided by A plus B divided by C plus D. So to get this, you would take 69 divided by 69 plus 101, and then divide that answer by 28 divided by 28 plus 152. This comes out to be 2.61. So those exposed to asbestos have a 2.61 times higher risk of developing mesothelioma compared to those not exposed to asbestos. The relative risk of 1 means that the incident rate was the same in both the exposed and unexposed, so the exposure is probably not associated with the disease. If the RR is greater than 1, then the incident rate was higher in the exposed than the unexposed, so the exposure was risky. An RR of less than 1 indicates that the incident rate was lower in the exposed group than the unexposed group, so the exposure was protective. If the RR is less than 1, you'll want to convert it into a percentage just like we did with the case control studies. What is the key difference between case control and cohort studies? Well, case control studies are initiated based on disease status, while cohort studies are initiated based on exposure status.